All right. So this is an interesting configuration, I thought, because arguably I'm one of the people that could tout the title of being Mr. OpenStack, and this is pretty much Mr. AWS to some extent. So I thought we could have an interesting conversation. But I wanted to start off with kind of a quick introduction. I don't know how many of you have read this, but the title of the session actually follows the title of the blog that I've recently written that has spurred a bit of conversation in the industry. Naturally, the title of the blog is Infrastructure Software is Dead. I think I on purpose left kind of a lot of topics open-ended there. And I wanted to kind of continue on some of the themes. I also think that quite a few people maybe kind of misunderstood the point that I was trying to make. But just to kind of reiterate and then set the stage, the one thing that is clear that we're seeing is that the infrastructure world right now, at least that's my view, has been kind of divided into two paradigms. There is the cloud paradigm, and then there is everything pre-cloud. And this does not necessarily mean public versus private. This just in general about there's companies that basically cater to the old non-cloud paradigm, and there's companies that cater to the cloud paradigm. And if we look at even the cloud paradigm and kind of zoom in on it, and this was kind of the point of my blog, is that the shift and this revolution is not so much about the software, it's really about the delivery model. And when you look at the public cloud delivery model, it's kind of very obvious, right? It's on the surface. So you can see that somebody like AWS hosts everything for you. They manage the infrastructure completely. They just give you an API to talk to the infrastructure. So in that paradigm, the infrastructure software is dead. But what we've actually discovered throughout the years kind of traveling the OpenStack journey is that there's a significant shift also on the on-prem cloud. So the on-prem side of things also has evolved in terms of the delivery model. So if you look, and Martin actually yesterday spoke to that a little bit. If you look at traditionally how any software, including infrastructure software, has been consumed, it's always been about somebody builds it, or they can take a downstream version from upstream. They can harden it, they can package it, they can make a pretty brochure around the benefits of this, and they put it out somewhere. And then you as a consumer, you will take that software and you will do something with it, like you will install it on premise and it will run. And if you look at Oracle, VMware, anybody in the infrastructure space follow this paradigm. Now, what we've uncovered of OpenStack is that pretty much everybody that's doing OpenStack, they follow this infrastructure as code paradigm, which is a completely different way of actually, completely different delivery model of software. And the idea here is that you don't take a package, download it, install it, make it work. You actually continuously consuming code. You push it into your CI/CD pipeline. And you stage it, test it. If things work, then you promote it to production. And this spans both public and private cloud, but the delivery model is radically different from what it was before. And this is actually one of the mistakes that I think at Mirantis we did, because we followed in the early days this traditional model of software delivery, where we'll take the code downstream, we'll package it, we'll make a pretty installer that you can click, install a cloud. But then when we go to the customers that are actually doing cloud proper, we realize that this is really not the way people do cloud. And even our PS team on-prem would then have to take this package that we've produced and decompose it into pieces that are relevant to the customer and feed it into their CI/CD pipeline. So the delivery model for on-prem is also dramatically changing from what we've observed. So I'm going to pause here and pass on to Adrian, because I wanted to kind of just hear your general thoughts. Do you agree with this? Do you not agree with this? And most importantly, how do you think this change in the delivery model actually affects the business opportunities for infrastructure companies going forward?
Yeah, so I think that certainly if you ask people what they want something that works, that doesn't change, right? And it's until they want a new feature. And then they want it to change. So the problem when you're looking at it from an operations side is that you're trying to do infrequent upgrades, and you do a project to do an upgrade. And a lot of the packaged software is delivered this way. I hear of people going, yeah, well, this team is going to go do the SAP upgrade for the next 9 months, and there'll be a bunch of deployments. And at the end of that, they'll run away and do something else. So that project-based model is kind of the traditional model a lot of enterprises have had in the past. And it's built around the idea that with the things you're deploying are relatively expensive and slow to do, so you need to bundle them together to amortize that expensive, slow thing, which was like procuring hardware and procuring software and doing all the things you needed to do. But nowadays, we're in a world where procuring hardware takes minutes or seconds, and procuring software is download from GitHub or whatever. The purchasing cycle has collapsed. The deployment cycle has collapsed. So a deployment can now seriously be done in a few seconds, by just firing up a Docker container and running it somewhere. So given that it's cheap, you should be doing it more often. And the reason why you bundled everything into one big release has sort of gone away. So then, to take advantage of that, the developer community has basically learned how to do microservices and break everything into small pieces that they can deploy independently. And you end up with this situation where there isn't really a version of something. When we were back at Netflix, there was no version of Netflix at any point in time. It's lots of versions continuously changing, right? And you might think, well, doesn't that break a lot, right? So the way you get out of that is that you make the changes one at a time, and you're making the smallest possible change. So it's a series of very small changes, and it's very easy to detect that that change broke and roll that change back. So this idea that you change one thing at a time is something that we kind of learn in our lives as like how you debug stuff, right? If your car's not working, you don't pull out all of the things and change everything and see if it works. You change one thing at a time to kind of figure out, to diagnose what might be wrong. So by making everything into the smallest possible incremental change, we've figured out how to build applications that can be changed continuously. And Mike, I've been out of Netflix for 2.5 years now, but running on public cloud, there's this thing underneath you. There's no real version of AWS either. It's changing continuously and it's adding new features. And they're trying things and they're rolling things back and forward to try and get stuff out. So they've figured out how to build a continuously evolving infrastructure. And so I think this is where the collision's happening, right? You've figured out how to get OpenStack working. We've figured out how to deploy it. But now you're on a 6-month update cycle. And it's only in recent releases that you've even had people have been figuring out, OK, now I have this in production. I have to do an update. And do I have to turn my entire cloud off to do that? Or do I have an incremental update model? So that's actually a hard thing to solve for. So one of the drivers is just the whole microservices development environment is that people are used to doing this, and the technologies and tools to build this are starting to mature. And what I've seen happening recently with OpenStack is you've incorporated containers, and they've containerized the internal services that make up OpenStack, and you're using Kubernetes to orchestrate those and deliver them. So now you've got the guts of the system broken into pieces, which can, in theory, be upgraded independently. But what you've actually really got is a distributed monolith, I think, right? The actual services are probably used to being tied together. So there's quite a bit of work to be done to break it into pieces that really can be updated independently. So that's one side. There's a whole other thing that's driving speed, driving the need to do updates in place. And that's the security vulnerability side of things. There's just more and more broken software out there where there's more exploits due to the fact that you're running some exposed piece of software. And now we have vulnerability scanners. Every vendor's got a vulnerability scanner. You know that this piece of your system is vulnerable, so you have to be able to track that deep in your system. Then you have to get in there, automatically replace it. One layer somewhere deep in a Docker container has something wrong with it. There's still people out there with, the Heartbleed bug was a year or more ago. I forget even when it was. But that stuff's still running in production. There are people that still haven't figured out how to track down everywhere they have that bug. There is people, Josh Corman said there were people downloading the Bouncy Castle, which is a stupid name, but it's a JavaScript security framework. People were still doing builds against broken 5-year-old versions with known vulnerabilities, right? You have to stop doing that and start building only against good source components. that you've verified using something like JFrog's X-ray product that looks at your artifacts, and then put it into production, and then have security scanners. Docker has one. A bunch of people have these scanners that will check your containers are secure. And when you find a vulnerability, you've got to automate replacing that component. And that isn't just the application, that goes deep into the infrastructure. So these two things, the ability and the expertise in doing continuous delivery has matured with the development community, and the requirement to do it from the security side. I think both of those are pushing on this, problem that you've got a system that is sort of designed that you kind of want to change it every 6 months.
So I'm curious, you technically work for a VC firm. Mm-hmm. So this whole transformation naturally affects your investment decisions, right? So the question is, provided that, what you're saying is true, what I'm saying is true, is that even for on-prem world, the delivery model for infrastructure software and probably software at large is now following this CI/CD infrastructure as code paradigm. Does that mean that pretty much the old delivery model of packaged software is dead? And then if it is, then what are potentially the opportunities if I want to start a business in the infrastructure space? And I don't want to compete with AWS. I don't want to make another service that will be better than AWS because that's not going to happen. So what do I do?
I think what we're seeing is there's really kind of two paths right now. I'm seeing, and this ties into the whole OpenStack story, is that I was talking to an executive of one of the big banks, and I told him about a new company I'd heard of, and his first question was, is it open source? It's like, yep. He's like, didn't care. If it wasn't open source, he was not interested.
Right.
So that's a whole new attitude that's spreading, right?
Yep.
So you've got a baseline, which is if you're going to get code and run it in your own system, you want that to be open source. Then the other way you can consume things is as a service. So if it's SaaS, you don't really need it to be open source, but you might want to make sure that you can, the implementation is going to stick around because yep. Sometimes companies disappear. So that's an area where what we're seeing is a lot of the things that used to be on-prem software, like SAP or Oracle Financials, is being replaced by Workday, which is a SaaS service, right? Yep. Or whatever. There's a lot of those. You see companies like Infor taking all of the manufacturing on-prem software packages and turning them into SaaS products, like they've done with sort of Lawson and things like that. So that's the trend. And what we've been seeing as a VC firm, we look for vertical SaaS is one of our categories. We look for a vertical. Some piece of the market, there is a product, which is the SaaS product that does that thing, yep. Right? And we go after it. And some of these are generally, this is something that Battery Ventures in particular has targeted, and we go after things that are sometimes some pretty unsexy areas that you wouldn't even think about. Nothing to do with infrastructure, maybe in finance, yep. Accounting or healthcare or something like that. There's a piece of administrative work that is normally done by this on-prem piece of software, and it's being replaced by a SaaS product that's being run somewhere else.
Yep. So I wanted to touch on one, I think, very important thing that you've said, which is kind of a recent epiphany for me. There is a lot of buzz in the infrastructure space around open source software. And one of the kind of, reasons to think about why that's happening is, okay, well, there's all these large hyperscale giants. They're open sourcing all of these cool things that you can take in and, do things the Google way, the Amazon way, etc. That's definitely one angle. But what I think is that this transformation that we're talking about, the transformation from actually packaged software to the CI/CD infrastructure as code fashion of dealing with infrastructure is arguably even a more important factor for open source in the infrastructure space accelerating. Because to your point, if I have a CI/CD pipeline and I'm managing my infrastructure as code, I need to have access to code, right? And I need to take that code and I need to maybe change it, apply configuration to it, and push it in. And you simply cannot do that with traditional kind of a licensable, downloadable, here's a software package model. Mm-hmm. One thing that I'd like you to comment on a little bit is what are your thoughts on how that affects kind of the dynamic around kind of a collaboration and partnerships, right? Because like I don't know what everybody else's experience has been, but from what I've heard, for a reason, like Amazon Web Services is not known to be very partner-friendly when it comes to the specific stack that they deliver. They have a marketplace, all of the stuff, but the actual software, hardware, all of that stuff, they do themselves, and there isn't really kind of much opportunity at this point to collaborate around the stack. And we at Mirantis ourselves are kind of struggling with it. So on one hand, we understand that we need to cater to this infrastructure as code delivery model. On the other hand, what if we want to partner with a storage vendor or hypervisor vendor or something like that? If we're delivering our software as a kind of a continuous stream of innovation into the customer premises, how other partners can be kind of a part of that story? Does it mean that we need to completely own the entire stack and deliver that? Or how do you go about it? Before it was clear, you put something out there, people take that, they test against it, it kind of works, maybe it works well, and then you have a bunch of partners that are tested around this product, you ship that. With the continuous delivery paradigm, it kind of changes everything. So what are your thoughts on how kind of the partnership dynamic in the space is going to evolve based on this change in the delivery model?
Well, if you look at, one way of looking at OpenStack is one of my analogies is kind of, if you think about a Linux box, you have device drivers for all these PCI cards that you can plug into it, and at some point people decided that that was the operating system that mattered, and if you had a device driver, if you built a card, you had to have a device driver. And if you up-level that to a data center, then the OpenStack interface has become the standard interface for controlling network switches and storage and all the other things you want in your data center, and there is a standard control plane for managing that. So I think that in the past, what you had was every major vendor had their own management tool that managed their product, whatever, EMC or whatever, Oracle or whoever, IBM, HP, they all had their own thing. And they've come together now to say, okay, we're just going to have OpenStack. So I think that has always been one of the big successes of OpenStack, was to basically get the industry to converge on one common set of APIs for doing that stuff. So the flip side of that is, if you've got a whole bunch of stuff in your data center and you've got a switch from some vendor that got bought by somebody a few years ago and now it's end of life, and who's managing that thing? Do you have to go in there and replace that switch because it's no longer got a supported driver and the drivers and interfaces are changing? Or are you going to find somebody to just go and sort of take care of that? So if you're continuously updating your system and one of the updates suddenly says, no, that switch is no longer supported, we're just going to drop it, and some piece of your system just sort of drops out in an update, right? You're obviously, you end up getting stuck on your dependency tree. So I think that managing that dependency tree, multi-vendor dependency tree, is actually a fairly large, complicated problem. It's like there isn't really a good solution to it. There's probably a bunch of least bad solutions to it. It's one of those things where it's never going to be perfect. But you have to figure out what you can do to keep everything going while you're also trying to change everything. So you want to keep the northbound APIs, the ones that developers want. You want to keep evolving those to add features, but your southbound APIs into all of the hardware act as constraints on that. So I think that that's where the partnerships are important, because the partners are supporting those devices as they all evolve, and getting all of that stuff hooked together. Over the years, there have been many attempts to do data center automation, and it's the permutation problem has always been the hard problem. There's just too many different versions of everything to manage, and getting everybody to collaborate on solving it once is a huge step forward. But it doesn't mean the problem goes away. It's still a hard problem to get solved. So
we're a little bit over time, but I wanted to kind of ask one last and very short question. This is kind of a question that I've always wanted to ask you as Mr. AWS, and this is something that I'm personally struggling with myself. So do you think that there is, going into the future, going to be such a thing as, on-prem infrastructure, or is it all going to be cloud?
There's always going to be on-prem infrastructure. It's going to be the people that have very special use cases or very large-scale use cases. I don't think it goes away. I think that what you're seeing right now is more and more of the greenfield applications are moving to public cloud. People are deciding that they don't want to, it's not a competitive differentiator for them to know how to run data centers, right? So that's the general sort of thought there. But as you're making that migration, but the Netflix migration was a 5-year move, right? Other people are trying to do things. They're at the beginning of a 5-year thing. As you go through that, you don't just leave the pile of junk or whatever you had in your data center. You've still got to make sense of it. So people are investing on both sides. So they're investing in automating the stuff that they're leaving behind, as well as building stuff on the new vendors. And there are definitely people, and there's people a wide spectrum. There are certainly people that are all in on the cloud, and there are people going all in still on-prem. I don't think that there is a universal answer to this, but we are certainly seeing the people are getting less afraid of running stuff on public cloud. The ability to run things there is getting better. The reasons why you didn't want to do it are getting better. I've seen some people, there was one like smallish startup or medium-sized startup saying that they were having trouble getting security verification for their on-prem stuff because they were just too small and the big vendors didn't trust them, the big customers didn't trust them, and by moving on to public cloud, they were actually happier with that from a security point of view. So we're starting to see some people kind of leveraging the fact that the security is now becoming a positive attribute rather than a negative one for some people, right? So you're starting to see some of the excuses for why you can't do it go away. But I don't think it ever goes away for a long time. I think Amazon's, 6% of IT spend or something now, which is a fairly large number, but it's a small percentage. There's still an awful lot more stuff out there to be worked on. And there's still things that are deployed much more. The cloud's very concentrated, right? There are a handful of very large locations, and more than half of all of the cloud is in Ashburn. Yeah. Right? If you look at the capacity of everything across the entire cloud, it is in Ashburn. It should say "Welcome to the cloud" on the town sign. And there is stuff around the world. You've still got to be able to deploy things in places that don't have good connectivity, and we need automation to do that. And if you look at Netflix, their CDN system is deployed. It's physical hardware. It's deployed everywhere. They've been doing that for years as well.
All right. Well, this is our sign to wrap up, I'm guessing. So thank you very much.
All right.
Was that it? All right. Thank you.
Okay.
Thank you.
Cheers. Thank you. Okay. Thanks.